Hello guys, this is Mr. Holly. We're going to be looking at lesson 13 together. This is just going to be a little optional add-on for you guys. What we're about to talk about today is not our primary strategy for how we would go between fractions and decimals, but it is a key math understanding. And it's the idea, and it's right here on this, actually on this next page that you can look at. And it's the idea that all terminating decimals can be converted to a fraction. A fraction whose denominator includes only factors of 2 and 5 can be converted to a decimal by writing it as a power of 10. So if we're going to change a decimal to a fraction, I'll just restate that, a fraction to a decimal, any fraction whose denominator can be made up of powers of 10, which would be prime factors of 2 and 5, can be converted to a decimal. So I'll just have to show this to you and we'll play with it a little bit. It's kind of just a pattern that we see in math that we can play with here. So what's the value of the number 2 and 25 hundredths? How can this number be written as a fraction or a mixed number? So easily I could write this as a fraction. That's 25 hundredths, so that's 25 over 100. Now, B asks, rewrite this in the simplest form, showing all the steps that you would use. Okay, so here's the steps. The idea here is that we could take any terminating decimal, we can always break this up into powers of 10. So 100 is 10 squared, right? That's 10 times 10. So it's a factor of 10 times a factor of 10. Now, we could take those factors of 10 and we could break those up into factors of 2 and 5. 2 times 5 is 10, times 2 times 5 is 10. 2 times 5 is 10, times 2 times 5 is another 10, so 10 times 10 is 100. You see how we've just taken this 100 and we've created prime factors? Let's do that same thing in the numerator. If I took 25 and I created prime factors, it would be 5 times 5. And now I can simplify this fraction and create, I have 5 in the numerator and 5 in the denominator, so those would cancel. I have another 5 in the numerator and another 5 in the denominator, so those would cancel. And my fraction would be 1/4. So this value, 2 and 25 hundredths, is the same as 2 and 1/4. And we simplify that by creating powers of 10 in the denominator and then looking at the prime factorization. So factoring them down into prime numbers. Specifically, those prime numbers are going to be 2s and 5s. Okay, let's look at the next one. What's the value of this number? 2 and 25 thousandths. Okay, how would I rewrite that in simplest form? Well, 25 over 1,000 is 10 times 10 times 10, which is the same as 25 over 2 times 5 times 2 times 5 times 2 times 5. And that would be the same as, well, let's just rewrite it. Well, okay, 5 times 5 over 2 times 5 times 2 times 5 times 2 times 5. All right, so now let's simplify this out. If I have a 5 in the numerator and a 5 in the denominator, 5 over 5, that's 1. Like those cancel to create 1. And 5 over 5 here, those would cancel, and that would just become 1 in the numerator. Okay? I would have 1 over 2 times 2 times 2 times 5. So 2, 4, 8. 8 times 5 is 40. 1 and 1/40th. So the number here is 2 and 1/40th. All right? This is not the primary strategy that we would use, but we can use this for all numbers that have a power of 10 in the denominator. Go to the next slide, or next page, excuse me. Sorry, I'm having a hard time getting my words out today. All right, write the number 3/20 as a decimal. Now, to convert this to a decimal, we can take 3/20 and we can make this into a power of 10. So if I were to make this into a power of 10, I would just I would rewrite this as 3 over 2 times 2 times 5. Is that right? This is 10, so 2 times 20. So what do I need to multiply by in order to get another 10? Every 2 times 5 represents a power of 10. So right here in the denominator, all I lack is a 5, and I would have a second factor of 10 in the denominator. Okay, so I'm going to multiply this fraction by 5 over 5 so that I can create 2 times 5 times 2 times 5 in the denominator. And in the numerator I'd have 15, and this is 15 hundredths, which is equal to 15 hundredths. Right, so I can convert to a decimal by creating powers of 10 in the denominator. Here's another example. 10 over 25. Well, that's equal to 10 over 5 times 5. If I want to create powers of 10 in that denominator, I would need to multiply it by, well, to get one set of 10, I would multiply by 2, and to get another set of 10, I'd multiply by another 2. So I would need to multiply it by 2 times 2 over 2 times 2, and I would get 40 over 2 times 5 times 2 times 5, which is 40 over 100, which is 40 hundredths or 4 tenths. Now we could have also taken this and simplified it. 10 over 25 is the same as 2 times 5 over 5 times 5. Those would cancel, and I would have 2 fifths. I would need to multiply by 2 over 2, and I would get 4 tenths, which is also equal to 4 tenths. So using this same strategy of just creating powers of 10 in the denominator, we can continue to go from fraction to decimal. Here's another example, 8 over 40. All right, let's factor this down into powers of 10 to see what we need to multiply by. All right, this is 40, so it is 2 times 2, that's 4, times 2 times 5 is 10. So 4 times 10, that's 40. Agree? I do. Okay, 2 times 2 times 2 up here. So right now what I would do is I see 3 factors of 2, 3 factors of 2. I would go cancel those out, and I would get 1/5. But I need this to be a power of 10. So what do I need to multiply 5 by in order to get a power of 10? I need to multiply by 2. I would get 2 over 10, which is 2 tenths. And now we've created a decimal. So again, we're just doing a prime factorization in the denominator and then continuing to try to get it to where we can have a power of 10 in our denominator. All right, 4 tenths. I would write that as 4 tenths. Now to write it in simplest form, I could do a prime factorization. That would be 2 times 2 and 2 times 5. The 2's cancel, and my fraction is 2 fifths. All right, let's skip down to C. That's 625 thousandths. This one's probably the biggest one we'll do. 625 thousandths is 5 times 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. 1,000 is 2 times 5, which is 10, times 2 times 5, which is another 10. 10 times 10 is 100, times another 10. So now I can simplify this by just canceling out. Let's cancel out each of these 5's. And now I can see that I have 5 over 2 times 2 times 2, 8. And that cleaned up pretty neatly. We went from this large fraction to 5/8 by just doing a simple prime factorization here and canceling out our common factors in the numerator and denominator. Okay, we'll skip down to E. We'll try that one real quick. With E, we would have, we're good, 12 over 1,000. Okay? 12 over 1,000. 1,000 is 2 times 5 times 2 times 5 times 2 times 5, and 12 is 2 times 3 times 2, or 6 times 2, right? Okay, cancel out, and I'm going to have left 3 over, that's going to be 25, times 2 is 50, 3 over 250. Now, in order to make this into a, that's going to, yeah, we're doing our simplest form fraction, so that's the simplest form fraction. Good. All right, let's look down here at the bottom. Let's see how many we have left on our clock here. We have 3 minutes left. Okay, let's convert these to an equivalent fraction. So, if I want to convert, let's start with 4/5. I want this to be a fraction that has a power of 10 in the denominator. How could I make fifths into a power of 10? Well, in order to create a power of 10, it has to be sets of 5 times 2. So I just need to multiply by 2 over 2. This becomes 8/10, and I can easily write it as a decimal 8/10. Now, what about 8/200ths? 8/200ths. How do I make that into a power of 10? Well, I don't think I need to multiply on this one. I think I need to simplify on this one. Let's look. 2 times 2 times 2 over 2 times 2 times 5, 2 times 5. Where is this coming from? 10 times 10 is 100, times 2 is 200, correct? And 2 times 2 times 2 is 8. These factors would cancel, and I would get 4 over 100, which is equal to 4/100ths. Good deal. So these are just some basic strategies. I want you to see the idea of using 2's and 5's and prime factorization as a possibility to simplify. We'll look at this last problem. Here you see it in exponential form, which is really kind of an 8th grade skill, but we'll get to it by the end of the year. But here we see 2 to the 3rd power, which means 2 times 2 times 2, and 2 to the 5th power, which is 2 times 2 times 2 times 2. So when I simplify this, I'm going to remove 2 times 2, like I'm removing 3 factors of 2. That's what 2 to the 3rd means, which means I'm left with 2 factors of 2 in the denominator. Here I have 2 factors of 3 and 1 factor of 3 in the denominator. So I'd move 1 factor of 3 there, and I'd be left with 1 factor of 3 in the numerator, and 2 factors of 2, and a factor of 5. Now when I look at this, I know that's not going to be a power of 10, because I don't have sets of 2 times 5. What I need is one more 5 there. So let's multiply. I'm actually going to get rid of this equal sign. Let's multiply times 5 over 5, and I get 15 over 2 times 5 is 10, 2 times 5 is 100. That's going to be 15/100ths, or decimal point 15 15/100ths. Alright guys, so these are your strategies that you can use, how we can use prime factors of 2 and 5 to go back and forth between fractions and decimals. It's not our strategy of choice, but it is something that you should be able to refer back to. Alright, thanks.